This is going to be the second lesson in the Intermediate Solid Modeling Autodesk Inventor module. We're going to be taking a look at the VEE pulley today, and the visibility is now switched on for this module, so if this was closed before, it's open for you now to be able to click into. So to find the VEE pulley, we need to come down past the bevel washer and we'll find it right here. Now, when we take a look at this, it's a little more complicated than what we've seen, and we can't build it with actual extrusions. What we need to do is actually use a new feature called REVOLVE, where we're going to create a center line on X, and we're going to be creating a 2D sketch profile of this shape right here with the diagonal lines. And what we're going to be doing is, after that sketch is constrained, we're going to create a revolve feature. So we're going to spin it on 360 degrees along the center line axes, and we'll create the wheel. I also want to mention that these speckles that you see here, this represents cast texture. So this wheel was most likely cast in a manufacturing process, meaning it was poured into a molten mold, and nothing cast is perfect. So basically, where a cast surface meets another cast surface, that edge can't be perfect. It has to be curved. It has to be radiused. So that's what this is talking about here. Rounds and fillets are 1/8 R. So wherever a cast surface meets another cast surface, that edge is slightly rounded. And you're also going to notice these check marks here. These are called machine surface finish symbols. So after this is cast, it's taken out. A machinist would put it in a metal lathe and actually bore out the center, meaning they would drill a hole, then use a boring tool to smooth it out, and then use a broach to cut a keyway into this. And up here, they would use a cutting tool to carve out the V grooves here. So this wheel could actually go into possibly a drill press, meaning a shaft would insert into the bore, that's the hole here, and there would be a rectangular key fitted inside the shaft, and it would lock to that key here, and that's how it would transmit motion. So the shaft would spin, it would be connected to a motor, and then the wheel here would be connected to the shaft, and a rectangular key would fit perfectly inside the bore of this wheel and also in a small groove inside the shaft. So that's how the motion would be transferred. So whenever you see a little check mark like this, that means machine surface finish. We also don't see those check marks on the bored hole, but we assume they're there because we look at this dimension. So the diameter of the bored hole is 1.127. So this is the only decimal value dimension on this entire sheet. All the other dimensions are fractional, meaning that a fractional dimension is not as precise as a decimal value. So the fact that this bore has a very specific diameter in terms of a decimal place value, it's considered to be very important because we know a shaft has to insert inside of it. So at this time, we're going to get started. So when you complete this exercise, right, make sure that you're viewing this on your iPad next to your monitor. Use your iPad as a reference tool, right? Don't click back and forth all the time. It's just poor practice, and it slows you down. And you'll notice when I complete my lessons, I'm never doing that because even though you can't see me, I have my iPad next to my monitor. So we're going to click into Inventor, and we're going to go to New. We're going to make sure we're selecting English and Templates, and we're selecting Standard Inch.ipt and hitting Create. We're going to 2D Sketch, and we're making sure that we're selecting the XY plane again. Last time we used the XZ, but I'm back to XY today because this is going to give me a front view start. So to begin, we're going to select line. We're going to find 0, 0 and draw a line horizontally. It doesn't matter how long this line is. We're not going to constrain its length. So I'm going to right click, left click OK to escape from the line tool. So this line here, we're going to select it and we're going to go up to format and we're going to find center line. We're going to select center line and that's going to modify that line to be a center line. Now this is very important because if we don't do this, we're not going to be able to revolve the sketch and we're going to have to work harder at also dimensioning it, well, which is also means we're constraining it. So we're going to hit line, and when we start drawing this, find 0, 0, but don't click. So just raise your mouse up on Y and keep X on 0. And we're going to travel up into about the 600s here. Then we're going to click. Let's zoom out a bit. So now we're going to continue vertically. And we're going to start to sketch this profile. So this is going to come over horizontally. We're going to come up on an angle. Now, notice when I swing this angular line, when I hit the y-axis, I get this little box that pops up. So that's when I want to click, because I want this line, the top edge of this angular line, to be exactly in line with the vertical line on the left side of the hub. So when you see this, click. And what is that? That is collinear, right? It happens automatically. You don't need to select it from up here. So when I see that, I'm going to left click. And then I'm going to come horizontally in about the 200 range here, 0.200s. Click. Now, watch what happens when I swing this line. This parallel symbol pops up now and again. And this is important. Even though we're not sketching this to be perfect, we're going to try to take some care in its initial creation. So this line I'm drawing right now needs to be parallel with this angular line I drew. So when you see that parallel symbol pop up, click. And you can see the double parallel symbols here and here, so we know that it's the same. We're going to continue on horizontally, and we're going to be in about the 500 range here, 0.500s. We're going to click, come up, and I'm going to pull this line up until that black horizontal line appears, right? Again, that's another collinear constraint. We're adding them as we go. So this is going to make dimensioning easier if we try to make things the same height and make things parallel. So we're going to click. We're going to continue on in the 200s. We're going to come down and we're going to touch here with our mouse but not click. And we're going to make that collinear. Click. Keep traveling in the 500s. We're going to come up, make this collinear again like we did over here. When you see that black line appear. Come over into the 200s. And again, we're coming down on an angle again and we're making this parallel. I also want to touch here but not click and blend that parallel with that end point to be perpendicular. Right? I'm not clicking that, but I'm just showing you what it is. So we need to get used to using some constraints, but the good news is we don't actually have to pick them. We can just make them happen as we sketch. We're going to come like this, and we're going to come down. Make that collinear, as you can see. Come out, come down, and then come back to here, where we started. Okay, so we've got our sketch. Now, it's not the most beautiful sketch in the world, as you know, but I did take some care in its creation. And a couple of things that are important here. is that the top left-hand edge, or corner I should say, is completely in line with the left side of the hub. And it's going to be the same on this side, and if it's not, it will be by the time we're finished. If I click into this, you can see that there's a center line running here and here. So that center line is showing that that left face of that hub and that top corner of the V pulley is aligned. So that's how we know. So again, the width of the hub is also going to be 2 inches, right? Because from the very top, the width is shown as 2 inches from here to here, and the center line aligns the hub, so we know that the hub length is 2 inches as well. So we're going to click back into this. Now, before we start constraining anything with our dimensions, it's very important that we lock, or I should say fix, this vertical line to the y-axis. Now, because this is not connected to 0, 0, I started the sketch offset, and the reason I did this is because I want to allow room or space for the bored hole that goes here. So if I start dimensioning this, it's going to be very confusing because it's never going to go purple. I'm never going to get any indication of what I'm constraining and what's not constraining, and that's going to be frustrating. Especially, it would be frustrating for me as someone who's experienced, and it would be way more frustrating for you who's learning. So what we have to do is add a manual constraint. We're coming up to constrain, and we're going to select fix, which looks like the padlock. We're going to pick it, and we're just going to select that left line. It's going to show that it's locked. Right? Any sketch connected to 0, 0 will naturally turn purple as it's constrained. The center line is the only thing connected to 0, 0, and whatever is connected on X or Y is always purple no matter what, even though we don't care about the length of it. So you'll see as we go what I mean. So that's now going to constrain as we start to dimension this sketch. So we're going to start with a general dimension. We're going to select the center line and the top of the bored hole, and we're going to pull a dimension out. Now, what do you notice about this dimension? It automatically gives you a diameter symbol, so it knows that it's supposed to be cylindrical, and it dimensions the extension line to the top of the bored hole, and it also dimensions the opposite side to nothing, because the center line is compensating. So I don't need to divide, because I'm only sketching half of this. I don't need to sketch the other half. The dimensions know, as long as I touch the center line, it's going to run them as their whole size. So I don't need to actually divide them all by 2. Which is pretty handy. So this is 1.127 check mark. Okay, so the next one, from here to here, center line to the top of the hub diameter. And notice how when you draw things collinear, there's less work. I don't need to run the dimension over here to do this side. It knows they're supposed to be the same. That's why you use the collinear constraint as you're drawing this. So this is 4. Check mark. Now we're going to work on the length of the hub. We're going to dimension from here to here, and we're going to make this 2, which will solve. Well, you know what? I made a mistake here. I'm sorry. I'm just going to back myself up here. This is supposed to be 2. I apologize. 2. Okay, now this is looking better. From here to here is 2 as well. All right. So the hub is fully constrained. Now we're going to work on the stem. It's listed as 3/8. Now, how are we going to center this into the hub? Right? This has to be dead middle. So we're going to run a dimension from the left face of the hub to the left side of the stem. And what we're going to do, now this is going to constrain it fully, but how do we figure it out? We know that the width of the hub is 2, so we're going to input a bedmiss formula into Inventor. So Inventor can do equations, right? Now bedmiss isn't anything too advanced. It's something that you should all know how to do from intermediate school, I would think. I'm pretty sure they cover this in math, even now as review. So we go Shift 9, we'll start a bracket. We're going to type 2 as our width, and we're going to subtract this stem width, which is 3/8. So we're going to type 3/8, and then we're going to go Shift 0, which will end the bracket. So we're taking this length, subtracting this width from it, and now what we have left over has to be divided by 2 because we have to divide it over 2 sides of the stem. So it's going to be backslash and 2. And we're going to hit check mark. And look what that does. It automatically centers the stem for us and tells us what that value is. If I was to run the dimension on this side, which I don't need, and again, it lists it as 0.813. If I try to drop that dimension, it gives me a warning, and it says adding this dimension will over-constrain the sketch. Choose accept to create a driven dimension. We don't need to do that because we already have this sketch solved in this bottom half, so we're just going to hit cancel. So moving on, what do we have to do next? We're going to work on, this is going to be the more challenging part to constrain up here. So let's start here. Let's dimension the length of this This is supposed to be 1/4 inch. This will not turn purple. And the other side is supposed to be 1/4 inch as well. And this will not turn purple. We don't have enough information to fully constrain this yet. So what we can do now is dimension the angle here. Now this is supposed to be 40 degrees included. If I run a dimension from here to here, it's pretty close. It says 39.55. I just can't edit this to be 40. I just can't do this and hit check mark and assume it's correct because I did not make sure that this was symmetrical. And it may look symmetrical to you or maybe it doesn't, but it really is not. So this dimension here, let's right click, left click OK, and we're going to select it and we're going to delete it because I can't guarantee it's equal. What we can do is run a dimension this way from here to here. And we're going to run this dimension as 110 degrees. And what we can do is run this dimension on the other side. It's pretty close. 110. It's got to be perfect. That's why we have to edit these dimensions. Now, how do I know that that's correct? Well, if I had a line running vertically from here to here and from here to here, I know that that angle would be 90 degrees on each side. And remember, I need to add 20 degrees on each side to get the 40. Right? So let's check it. So let's run a dimension from here to here, and what do we get? We get 40 degrees exactly, and I know that it's symmetrical because I ran that dimension on both sides. So if I drop this dimension, it gives me the same warning you saw earlier about adding a dimension will over-constrain the sketch. So let's choose accept this time. So when you choose accept, all it does is it just runs the dimension, but it keeps it in brackets. But this dimension really doesn't do anything. It doesn't constrain anything because it doesn't need, Inventor knows it doesn't need it. So there's no point in dropping it. I just wanted to show you what would happen if you ran a driven dimension. So right click, left click OK. Let's select this and let's hit the delete key. Now, because we made this collinear, hopefully this side will already be 110 degrees. and it's not. So let's check both of these. All right, so we got that one done. We know this is 40 degrees as well. And we also need to set the depth of the V grooves. So it shows in the bottom left-hand corner of the iPad image that it's 5/8. So we're going to run a dimension from the top diameter to the bottom of the groove, and we're going to set this to be 5/8. And we're going to do the same thing on this side. And okay, so this, it's counting this as over dimensioning because again I made that collinear when I drew it, so it's associated with this one. I thought that these angles were, but I guess I didn't make them collinear, but I made the depth of the groove collinear to this original one, so that's why we're getting this warning. So we're just going to hit cancel. Now we're going to set our width. This needs to be 5/8, and also on this side. And look what we have here, right? So this line here is going to need to be fixed. So what we can do, the easiest way to fix this, because I know these angles are correct, and I know that this line has to be parallel with this line, we can go up to our Constrain toolbar, pick parallel, select this line and this line, and it's going to force this line to be parallel with this one. So if that problem comes up, that is your solution right there. All right, moving forward, we have to set the diameter of the bottom of the top of this. So we're going to go dimension from here to the center line. So this is going to be 4 inches. All right, and look what happens when we do that. We get this thing pops down like this. So this is kind of confusing. So what we're going to do is we're going to undo this dimension right here, and we're going to run a dimension from here, and we're going to make this one 6, and look what happens. So what we're going to have to do is, the first thing I would recommend is centering this, right? We know that the top left-hand corner is already aligned with the left side of the hub. We know this side is not. So what we're going to do is we're going to center this. So we're going to go dimension. We're going to do this the same way we did the stem to the hub. We're going to go stem to the top right of the wheel. So we're going to run a dimension from here, and we're going to put the same formula in. We're going to go bracket 2 as our length. We're going to subtract the stem, which is 3/8, because it's dimension to the stem to here, and we're going to go divided by 2. All right, so that's going to center it. So all we have left to do now is fix these 2 dimensions. So we're going to run this dimension here as 4, and this one here as 6. And that fixes it. So now everything is constrained, right? It was purple before, but I hadn't edited these dimensions yet, right? All the dimensions have to match what is seen on this image right here. So again, let's do this one first because it's the smaller one. Edit this one to be 4, again, which pulls that down, but making this one 6 basically balances it out the way it needs to be. right? Yours may or may not behave like this. When you sketch yours, you may have, everyone's is going to be a little different on the way to getting the sketch constrained, but as long as you're ending up with the result that looks like this, that's all that matters. So it may take you 1 attempt, 2 attempts, or maybe even 3 attempts to get this to work. And if you're having trouble with this, you need to let me know, and I will assist you. So hit Finish Sketch, and all we have to do now is hit the Revolve feature, and it spins it around, gives us a preview. So it's spun it 360 degrees along that center line, and we're going to hit OK. And there is our wheel. Now, one thing we're not going to do to this, so do not do this, is cut a quarter of this away, like you see here. Right? The only reason it's done here is to allow you to view the sketch profile. So we're keeping ours completely round. So at this time, I'm going to save it. VEE pulley, put it on my desktop, and that is how you sketch, constrain, and revolve that VEE pulley. So it's a little bit, the sketch is a challenge to constrain, but follow my video and you shouldn't have any trouble. And again, if you have any trouble, you need to get in touch with me and we need to figure out what the problem is. All right, so take care for now, good luck, and I will talk to you soon.